This video lecture will go over the different types of faults with special emphasis on how to identify and sketch them. First off, we'll start with a definition. What is a fault? A fault is any break in a body of rock marked by the relative displacement of strata on either side of a particular surface. And I'll show you plenty of photos in a second. First off, why do we care? Why are we studying faults? Well, they are the places where earthquakes happen. They provide evidence for plate tectonics, and they also reveal Earth history. So lots of really useful information, not to mention saving lives in terms of earthquakes from studying these features. First off, I wanted to go over these terms hanging wall and foot wall, right? So this is actually old mining terminology from when miners used to work, and they would find they were often mining at places that had faults, and so they needed some terminology. And the hanging wall is called the hanging wall because it is the upper block where they would hang their lantern that you probably can't even see anymore now that I have covered it up. There you go. So the miners will hang the lantern on the hanging wall, and they would stand on the foot wall. And so that is where this terminology comes from. The hanging wall is always above the fault, and the foot wall is always below it. So it's not about what's on the left or the right. It's about what's up or down. So you can always, always, always just put your finger right on the fault, and if you move up, you're in the hanging wall. Now, as we go through what happens with all the different faults, I'm going to be giving definitions relative to the hanging wall, right? Saying the hanging wall moved up would mean that that went up along a fault like so. And we're not going to bother talking about what happens to the foot wall because it's just obviously going to have to do whatever the opposite of the hanging wall is. All right, so we're going to start with normal faults. Here's an example of a normal fault. Hopefully you can identify the fault itself. The next thing to look for is part of the rock that has been displaced, okay? So this is all the same bit of rock, but it's been displaced by the fault, right? So if you put your finger on the fault, doesn't matter where, and you move up, right, that puts you in the hanging wall. So this is the hanging wall, and it looks like the hanging wall in this instance has moved down relative to the foot wall. And that is actually the definition of a normal fault. It's when the hanging wall moves down. So we can sketch that, and we normally are just going to draw in a fault. And since you don't have your box already drawn, I'm going to put it inside of a box. And then you would just draw some strata that have been offset, like so. And then you have to include your arrows, like so. Now, what makes this a normal fault is because this top block, this hanging wall, moved down, right? So I could easily draw another fault in a different orientation, and there's my bed that's going to go all the way through. These should really be straighter lines than I've drawn, but that's okay. In both instances, the block on the top has moved down, and so this is a normal fault. Here is a different type of fault. This is called a reverse fault, right? So while it's normal for hanging things to fall down, that's one way to remember the normal fault has the hanging wall moving down. Reverse is just the opposite. So first we identify that fault, and then we can see the layer that's been broken up. And this time that layer has had the hanging wall move up. This is the hanging wall. So when the hanging wall moves up, we call that a reverse fault. We can, of course, draw that ourselves. In this instance, the hanging wall has moved up. That's supposed to be, let's redraw that arrow. And again, the orientation doesn't matter, so we could have just as easily drawn it in this direction, hanging wall, moved up. Okay. So, both of those two types of faults were examples of what's called dip-slip earthquakes, and that means that we draw them in cross-section. Strike-slip earthquakes aren't very useful to look at in cross-section. If I was going to draw a cross-section, it would just be a vertical line like that. So instead, we draw them in top view, okay? So here's a photograph, top view, of a strike-slip fault. There's the fault, and you can see there's a feature that's been offset, and it's been offset this way. Now, this is called a right lateral fault because if you approach the fault from either direction while following a feature, so if I'm walking along here and I get to the fault, I'm going to have to step to the right to continue on with my feature. And notice that this works from both directions. If I start walking along the feature in this way, I'll still have to step to the right to keep following along on that feature. So to draw strike-slip faults, we always draw them in top view instead of side view. And I'm just going to draw my fault in here. And I'm going to draw, maybe this is a river or something. And it has been offset like so. And I'm just going to draw another one in a different orientation for you. So that is my fault. And that is my river. And if I was inner tubing down it or something, I would have to move to the right in order to stay in the river. So that's your right lateral fault. Of course, there's also a left lateral fault, okay? So to draw a left lateral fault, there's my fault. How about that? There's my fault. And now we'll go in and we'll draw something that is being cut by it. But this time, to stay on that feature, you have to step left, right? So if I was going along, I'd have to move to the left to keep going along. So we call that a left lateral strike-slip fault. And we can draw arrows like so. All right, now that we're familiar with all of that terminology, we really need to take a step back and put our faults into the context of plate tectonics. So if we look at this top representation here, we can see that we have a fault, that's the surface feature, and we want to answer the question, has the lithosphere shortened, lengthened, or neither? In this instance, it has done neither, right? And the type of fault, can you see what type of fault this is? Hopefully you said strike-slip. In fact, it is a left lateral strike-slip fault, because if you were sort of walking along, you would have to turn to the left to keep going. So that is a left lateral strike-slip fault. The type of plate boundary where you find that type of fault is a transform boundary, because that is the place where shear stress is acting, and shear stress, that side-to-side motion, is what's going to create that type of fault. Okay, so for our next fault, we have, in this instance, the lithosphere is actually shortening. There you have it. And can you see what type of fault this is? Hopefully you said reverse, right? So this block is the hanging wall, and it has moved up relative to the foot wall, making that a reverse fault. And the type of plate boundary where you're going to get that happening is where you have two blocks coming together. So do you remember the word for that type of boundary? Hopefully you said convergent. And the type of stress acting at convergent boundaries is, of course, compression, right? Compression. Now, for this final one on the bottom, The hanging wall is still going to be, if you put your finger on the fault and you move up, you're in the hanging wall. Okay. And this time the hanging wall has moved down, which resulted in lengthening that bit of crust there. This is, of course, a normal fault. It's normal for hanging things to fall down. The hanging wall has moved down, so that is normal. The plate boundary type is going to be the one where two things move away from one another, which is, of course, divergence. And the type of stress acting at a divergent boundary is actually tension, right? Like if you were to pull a rope and put tension on that rope, it's the same thing here. So you have normal faults occur at divergent boundaries where the type of stress is tension. And that concludes the faults video lecture. If you haven't already, go ahead and practice sketching each of the different types of faults now.